Okay, hi guys. So in this lecture, we'll be discussing about the mechanism of nitration. Okay, so let's get started. So mechanism of nitration. Okay, so we have something like this: H2SO4, and we have HNO3. So what happens in the first step is this H from H2SO4 and OH, HNO3. I missed a O in between. OH. Okay. So now in this case, H2SO4 is a stronger acid than HNO3. So H would be taken from the H2SO4 and OH will be taken from HNO3 to form a water molecule, and as a result we will get something like water molecule plus HSO4 minus and NO2 plus. Okay, and this H2O again reacts, again the H2SO4 reacts with the water molecule to form HSO4 minus and HNO3 molecule, HNO3 plus. Okay, so in the second step what actually happens is we have this benzene ring and we have also a NO2 plus. Okay, this benzene ring actually reacts with NO2 plus to create a Wheeler intermediate. We have looked about it when we were discussing electrophilic aromatic addition substitution reaction. Okay, and this is called arenium Wheeler intermediate, and again in presence of HSO4 minus, this HSO4 will attack on the hydrogen present on the ring and will actually form a negative charge on this carbon atom, which as a result forms a double bond between the positively charged carbon atom and itself. So we have something like this structure formed, obviously with H2SO4 also formed. Okay, so we have something like, in the overall mechanism we used 2 moles of H2SO4 and 1 mole of HNO3 for the reaction to take place, which actually converted into NO2 plus, H3O plus, H3O plus and HSO4 minus. Okay, so this is used in the ratio of 2:1. Okay, so before continuing forward, let me actually clear some of the doubts which students regularly have, that this ion is known as nitronium ion, this is known as nitrosonium ion, this is known as bromonium ion, and this is known as diazonium ion, and R plus is known as carbonium ion. So just a basic nomenclature of all these intermediates. This is known as carbonium ion. Okay, so let's actually delve into the characteristics of nitration. So characteristics of this reaction are, we have first that when mixed acid is used for nitration, HNO3 will act as a base and H2SO4 will act as an acid. So when mixed acid is used for nitration, HNO3 will be used as base and H2SO4 will be used as acid. Second point is kinetic isotopic effect is not observed in this reaction. So kinetic isotopic effect or effect rather is not observed in this reaction. And what do we mean by kinetic isotopic effect? Kinetic isotopic effect means if I replace C6H6 with, let's say, C6D6 or C6T6, which is deuterium and tritium ion, which are isotopes of hydrogen. So if we actually replace the benzene, substitute benzene with D or T atoms on all the 6 carbons, even then this is called kinetic isotopic effect. And kinetic isotopic effect is used to see if the rate of reaction rate of reaction is actually determined by using different isotopes of the H atom. Okay, so we actually found out that rate of reaction or rather rate of nitration is actually same in all the cases. Okay, so why do we see this case? Because if you see the RDS or redetermining step in the nitration process, RDS is something like this with electrophile as NO2, and that gets converted into something like NO2 here, H here. Okay, and positive charge obviously here. So this is the RDS. Okay, so in the RDS it does not matter whether benzene ring is substituted with H atoms or D atoms. It just happens. It is independent of whether H or D is there. It is just dependent on how much energy is needed to break the bond between two carbon atoms. Okay, so let's look at the third characteristic. We have something like Van 't Hoff factor is 3.8, not 4, due to incomplete protonation of water. Okay, Van 't Hoff factor. So just remember this for the time being. This won't be asked in depth into JEE level competitive examinations, but just the name would be asked, that what is the Van 't Hoff factor for the nitration. So just remember it for that purpose. So it is 3.8 and not 4, and the reason is due to incomplete protonation of water. Okay, there are many parameters which are required to calculate the Van 't Hoff factors. We won't be delving into this topic too much. Okay, this is out of syllabus for the time being. Okay, let us discuss some examples here. We have something like aniline, and we are passing it through concentrated HNO3. So what will happen here is we would get something like this: para substituted NO2 plus ortho substituted and meta substituted as well. Okay, and in which ratio do we get it? This we get as 51%, this we get as 47%, and remaining is 2%. Please remember this example. This is an important example. So how does it happens is, when it comes in the contact of acidic medium, what actually happens is this NO2, this NH2 acts as a base. Okay, as a result we get something like NH3 plus, and hence it becomes, this is called anilinium ion, and this becomes meta directing. Okay, as a result we actually see this compound also in high proportion along with the ortho and para directing NH2 group. Okay, so with this we come to an end of this lecture. In the next lecture we will be seeing some more examples of nitration. Till then, good luck and goodbye.